Hello and welcome. In this video we will discuss the power rule of a derivative for any integer. We know from our previous video the derivative of x to the power n, where n is a positive integer, is equal to n times x to the power n minus 1. Now we will prove this is true for any integer, whether n is positive or negative. Now let n equals to a negative number m. That gives us derivative of x to the power minus m is equal to the derivative of 1 over x to the power m. Using the laws of exponents, we can write x to the power negative m as 1 over x to the power m. Now, using the quotient rule, which is negative, either you can use the quotient rule or also you can use the rule of reciprocals. Now, using the quotient rule or the rule of reciprocals, this gives us the denominator times there's no negative here, denominator times the derivative of the numerator, which is 0, minus the numerator times the derivative of the denominator. Divided by the square of the denominator. Or you can use the reciprocal rule directly, which gives you negative derivative of the denominator divided by the square of the denominator. Now that leaves us with negative. Now the derivative of x to the power m is m x to the power m minus 1. Now in the denominator we have x to the power 2m. Using the laws of exponent, x to the power m squared can be written as x to the power 2m, which is negative m x to the power m minus 1 minus 2m. Again, using the laws of exponents, which is, for example, see, let me write this down here. For instance, if we have x to the power a divided by x to the power b, this can be written as x to the power a minus b. So this is exactly what we did here. So now this becomes negative m x to the power minus m minus 1. Now we started with letting n equals to negative m, so replacing negative m with n gives you n x to the power minus m is n minus 1. Therefore the derivative of the function x to the power n is equal to n times x to the power n minus 1, irrespective of whether n is positive or negative.